Now let's imagine a large atomic nucleus. So I'll just draw a big circle. I won't draw all the little protons and neutrons, but I'll draw some of the neutrons here to make this point. Let's imagine there are a lot of neutrons, and large nuclei tend to have a lot of neutrons. And let's imagine we can find a place like this right here where there's a neutron there that isn't surrounded by protons, or it doesn't have protons around it. Remember that protons are what allow the neutron to be stable. The neutron by itself is not stable, but protons around it will keep it from being decaying. This neutron right here, because it doesn't have protons around it, it will undergo this process. The neutron decays into a proton and an electron. Okay, so what happens, imagine that happening right here. Well, what happens then is instead of a neutron right here, we get a proton and an electron comes flying out. Okay, that's beta radiation right there. The electron flying out. And this neutron has changed into a proton. Now remember, the atomic number of an element is the number of protons that it has. And the number of protons, the atomic number, determines what element it is. So this is now a different element. It now has one more proton than it used to. But something else can happen. Because it has more protons, there's more electrostatic force pushing it apart than there was before. So again, the nucleus is unstable. And if it's a large nucleus, if the particles are already spread out to the limit of the range of the strong force which is holding them together, this added proton provides just enough extra outward electrostatic force to cause a piece of the nucleus to break off. And what can happen is this. That additional electrostatic force can cause a little alpha particle to pop out. That's essentially two protons and two neutrons leaving the nucleus. So now it's changed again. Now we have a different atomic number in the nucleus because these particles have left. The nucleus is now smaller, it's a lighter weight element, and it's a different atomic number, it's a different element. And all of these other particles are left behind. I haven't drawn them in here, but we can imagine them all left behind. But what's left is a different element, and this process is called transmutation. It has changed from one element into another. And in that little process, we've seen alpha and beta radiation. The element here has become smaller. That's why we consider this to be decay. There's becoming less and less material there as it decays. And it's radioactive because we've seen two types of radiation emitted in this particular little process that we've been looking at here.